There are many mysteries behind the science of water activation, and perhaps no one has been trying to unravel them more than Dr. Ernst Hoche of the WEM Institute in Vienna, Austria. After 10 years as an assistant chemical analyst at the Technical University of Vienna, Dr. Hoche was appointed as a professor of chemistry at the TGM, a distinguished technical and research institute where he has been a pioneer in the field of chemical investigations for over 25 years.
My very first experience with water activation is about 88, 89, long time ago, when a Swiss company ordered me to investigate whether the damage of water pipes in a very old building in Vienna was due to the influence of a recently installed water activation device. I'm normally very skeptical when I hear about something new, and I was quite skeptical also in respect of water activation. I found out the activation device was really working, and moreover better working than expected, because the lime which had been deposited within these tubes since many years had been removed particle by particle and exposed the holes and the fissures in the old tubes. That led me to start to be interested to water activation, because I am an analyst and usually want to know what is the reason for any effect. The problem was I could not at all understand how the activator was working, but I had to accept it is something that is working. There is some change in the water, and my duty I felt to do is to prove that there is something reproducibly changing in the water now. So the reason for the changes are the so-called clusters. That's nanometer large, very quickly switching and changing formations of not a single, but thousands and millions of H2O molecules. The activation reduces normally the size of those clusters to smaller and more rounded ones.
This discovery of how activation was rearranging these clusters led to a deeper understanding of the effects of activated water, as well as to some surprises.
Sometimes we had some additional unexpected effects when we had installed water activation systems. For instance, at coffee machines, there was not only that the pipes were set free from lime, but additionally that the taste of the freshly brewed coffee had been significantly changed. The consequence was they had to reduce the whole amount of the coffee powder to some 70, 80, something like that %. After the reduction of the amount of coffee powder, the customers felt the same quality of the coffee they were used to. The following experiments should show that the water activation is a reality, that it's not a fake and fantasy and something like placebo, but physical existing reality.
The first of these experiments involves the same substance that Dr. Hoche encountered in his first experience with activated water, lime. After preparing a few samples of water activated using the WEM Living Water Activation System, as well as normal, non-activated water, the samples are placed in an undisturbed environment, where they are allowed to evaporate for 3 days. After 3 days, we find that lime crystals have been deposited at the bottom of the sample dishes. Upon initial investigation, we see a visible difference between the deposits left behind in the non-activated water and the deposits left behind in the activated water. Using close-up photography, we see that in the non-activated water deposits, the lime has left behind very fine crystals that have assembled in densely packed rows, and that the overall deposit has a very refined edge, mimicking the circumstances that allow these crystals to accumulate in water pipes, eventually leading to severe damage. In the WEM activated water samples, we see the lime crystals are much coarser, less organized, and more widely spaced apart. These types of crystals resist the buildup that commonly occurs with more refined deposits, as their large size and lack of agglomeration allow them to be more easily dispersed in the flowing water, preventing them from accumulating in a pipe. The binding properties of water surface tension are what determine the size of each individual water droplet. But what happens when, through the process of activation, the surface tension, and therefore the size of the water droplet, is reduced? Through a simple experiment using a commercial detergent, we can observe the results of a reduced surface tension through interaction with the WEM Water activator. We start by adding 40 milliliters of activated and non-activated water into two identical containers. Equal amounts of a commercial detergent are applied to both samples, which are then vigorously shaken for a period of 30 seconds and allowed to settle. Left standing, the vessels reveal that the reduced surface tension of the water activated using the WEM Living Water system, seen here on the left side of the screen, produces more and stiffer foam, while the normal unactivated water on the right produces less and softer foam. We repeat the experiment, this time adding a powdered dye to represent the dirt found in a typical wash cycle. The powder is added to an activated as well as non-activated sample. An equal amount of detergent is added to each sample. The samples are then shaken vigorously, then allowed to settle for a period of 10 minutes, which we have compressed here to 10 seconds. Again, we see that the WEM activated water sample on the left side of the screen has produced more foam. But what we also see is that the foam in the activated side has turned darker, as it holds more of the dirt particles than the non-activated side. This translates into an increased ability of the detergent to remove dirt from the contaminated water, resulting in the need for less detergent used to clean the same amount as non-activated water. Another result of the reduced surface tension of WEM activated water is the increased speed of evaporation, as we see in our next experiment. We place samples of activated and non-activated water into identical open containers and place digital thermometers into each. A steady stream of air is evenly applied to both samples, accelerating the process of evaporation. By measuring the change in temperature of the water using digital thermometers, we observe the expected drop in temperature that occurs as the warmed water molecules evaporate into the surrounding air, cooling the remaining water. But what we see is that the WEM activated water sample here on the left cools down more quickly and by a larger amount as a result of the smaller droplet size and the reduced surface tension of the water. When applied to a larger scale, where a large amount of water is the main component of a cooling system, we can see how this reduced surface tension would result in a more efficient and therefore less costly system simply through the introduction of the WEM Living Water system.
There is a lot of potential in water activation. It's very interesting and exciting to have further experiments and so much to be investigated. Certainly the installation of the WEM Living Water system will lead to reduced costs, to cleaner dishes, to lower demand of detergents. An application of the WEM Living Water system is possible wherever water is flowing.